Good morning, everyone. I'm very happy to be able to talk to you today. My name is Kazuhiro Miyahara. I'm from Tokyo in Japan, and I'm a researcher of NTT. Today, I'd like to talk about integer encoding for combinatorial optimization problems. My presentation consists of 6 parts. First of all, I'll introduce the outline of our research. Second, encoding format QUBO and the usual integer encoding for one hot. Then, our proposal to scalably encode integer encoding with limited binary variables. After that, evaluation of the scalability of usual encoding and our proposal. Finally, future directions and references. Okay, I'd like to start by talking about the introduction. To efficiently solve combinatorial optimization problems, several companies have developed specialized computers such as D-Wave's quantum annealers and NTT's coherent Ising machines. I would like to emphasize that these computers employ QUBO as the native input format. Usually, one-hot encoding is used to represent integer variables which consumes many binary variables. This limits problem scale that can leverage specialized computers. In this talk, we propose scalable integer encoding QUBO to reduce the consumption of binary variables. In this section, I will show you definitions of QUBO and one-hot encoding. QUBO is minimization problem of quadratic binary function. If you can formulate several constraints of binary variables, some of them mean conjunction of the constraints. One-hot encoding represents integers with single one variable and all the other 0. We can formulate this constraint as a minimization problem as the one-hot function. Then, we can also formulate mathematical constraints equal and not equal as EQ and NEQ functions. In the next section, I will propose QUBO encoding. QUBO is based on the 2-base numeral system. Therefore, it consumes only logarithmic order binary variables. The quadratic polynomials EQ and NEQ are for equal or not equal constraints. NEQ requires additional integer variable gamma and delta, but they consume only logarithmic order binary variables. We evaluated consumptions of binary variables between one-hot encoding and QUBO encoding using the graph coloring problem. In this evaluation, the number of colors k is scales from 1 to 300. A color for prefecture is represented by an integer with one-hot or QUBO encoding. In both cases, graph coloring can be encoded by not equal. Now I'd like to show you the plot. QUBO encoding scales better than one-hot encoding. For example, with 2048 variables, number of colors k of QUBO encoding can scale 6 times as many as one-hot encoding. Finally, let me talk about future direction. QUBO computers also have limitation on a value range of the elements in matrix Q. However, QUBO encoding tends to require a large range than one-hot encoding. We are going to study how to minimize the value range. Additionally, we will evaluate the constraint of less than as function. That's all I have to say on this poster. Thank you.